Hi friends, this is Rashekar, a GATE faculty for electrical machines. Today in this video, we are going to discuss about star-delta connection. So for this star-delta connection, first of all, phase turns ratio. Phase turns ratio is common for all x is to 1, this is fixed, and line turns ratio is equals to, what is the line voltage for star? For star, line voltage is equals to root 3 times of phase voltage, and for delta, line voltage is equals to phase voltage and turns ratio x. So phase gets cancelled. So the answer is x is to 1 by root 3. X is to 1 by root 3 is the line turns ratio of star delta connection. Now it is completed. Now let's go for connection diagrams and configurations. First, to see here, these are the three phases of my winding of primary. Three phases of primary winding, and these are three phases of secondary winding. Of course, we know that here the dotted notations, and of course we know that capital A, capital B, capital C, small a, small b, small c, and A1, B1, C1, A2, B2, C2, A2, B2, C2, A1, B1, C1, all these are you know very well. Now let's go. This is a star connection and this is a delta connection. So star connection nothing but, actually this is the standard star connection, and delta connection. I am doing delta connection. See here, this A1 is connected to B2, this B1 is connected to C2, A1 is connected to B2, and B1 is connected to C2, and C1 is connected to A2, and C1 is connected to A2. This is a star and delta connection diagram. Right? Let's draw the arbitrary star. This is a additive polarity. This is a additive polarity, additive in nature. So how the star, generally this is neutral, and this is a capital A2 and capital B2 and capital C2. This is capital A, capital B and capital C, A, B, C phase sequence followed by this. This is generally the arbitrary star for this one. Now let's draw the arbitrary delta. And here this is additive polarity, that's why vectors are in phase to each other. Let's see, this is A, and here also this should be A, and this is B, and this should be B, and this is C, this should be C. This is the arbitrary delta. The vectors are in parallel to each other. Now let's see, the A is in between. A is in between A2 to B2. A2 to B2, A. B is in between B2 to C2. And C is in between C2 to A2. And represent a star in this delta. Now let's take the clock. Here 12 o'clock, here 1 o'clock, here 11 o'clock, here 6 o'clock, 5 o'clock, 7 o'clock. You know very well about this. Now superimpose this primary and secondary vectors. This is the minute sign. We know that always minute sign is at 12 o'clock. And this is the hour sign or secondary vector. This secondary vector, where is secondary vector? This is A. Where is my secondary vector? Here is. This is our vector we have to consider. Now see, this is my hour sign. This is my small a. Now tell me, what is the angle? If it is here, this is 180 degrees, but this is greater than 180 degrees. So how we can represent this? Primary is the star. Primary is the star. Secondary is the delta. Secondary is the delta. And the time is 7 o'clock. It is nothing but 180 plus 30 degrees. 180 plus 30 degrees is nothing but 210 degrees. This is the 210 degrees angle for star delta configuration. Very simple question. Is it okay? This is also important. They will ask you question in GATE. So this is one configuration, that is 180 plus theta. Let's go for next configuration, how it was. Let's see the next configuration. Let's see here. These are the primary windings, and these are the secondary windings. These are the secondary windings. Let's see. We know that this is A1, A2, B1, B2, C1, C2, A2, A1, B2, B1, C2, C1, A, B, C, A, B, C. It's a general thing. And the first one is the star. This is a star with neutral. Second one is the delta. Delta is normal connection is completed. Now modified connection. In this modified connection, how we can draw the delta? You know that how we can draw the delta like this. The A2 and B2 and C2 also connected to here. This is the modified delta. This is the modified delta. Now, actually here the dot notations. Actually here the dot notations. But this is here undotted condition. This is dotted condition. Dotted and undotted. Nothing but additive polarity or subtractive polarity. This is a subtractive polarity. Subtractive polarity because this is open circuited. This is connected to. Here these are connected to like this. So this is dotted notation, this is undotted notation. Let's draw the arbitrary star. Let's draw the arbitrary star. This is the arbitrary star A, B, C, A2, B2, C2. Arbitrary star is okay, which follows the clockwise notation, phase sequence. Let's draw the secondary or arbitrary delta. So see, if A is here, then our small a should be like this. And if B is like this, nothing but our B should be like this in opposite direction. In opposite direction. And my C is like this. So our C should be like this. Our C should be like this. A, B, C. These are the three vectors. Of course, this is A, B, C. A, B, C. That is enough. And see how the representation is there. This is my star representation. Now check it once. A is connected in between. A is connected. First of all, B. The B is connected in between A2 and B2. A2 and B2. B is connected in between A2 and B2. and C is connected in between B2 and C2. B2 and C2. And A is connected in between. A is connected in between C2 and A2. So A, B, C. A, B, C. This is enough. Let's take the superimposition on the clock. 12 o'clock, 11 o'clock, 1 o'clock, 6 o'clock, 7 o'clock, 5 o'clock. Now superimpose. This is the minutes hand always at 12 o'clock. And my hours hand is there. My hours hand is there. This is my hours hand. Now tell me what is the angle. Now tell me what is the angle. The primary is the star. Secondary is the delta. And the time is 11 o'clock. 11 o'clock nothing but plus 30 degrees. Nothing but 0 plus 30 degrees. Nothing but leading. Advanced, nothing but leading. This is the three-phase transformer connections in the star delta. This is also very important. So here we saw two configurations. One is 180 plus 30 degrees and other one is 0 plus 30 degrees. Remaining two are there. One is the 0 minus 30 degrees and other one is the 180 minus 30 degrees also is there. Yes or no? Yes or no? You have to draw them. Are you okay? Understood? You have to draw 0 minus 30 degrees and 180 minus 30 degrees, how it was. Right, do it fast. So this is understood? Is it okay? We are going to discuss about star delta connection, remaining two configurations. Let's see here. These are the three phases of primary and these are the three phases of secondary. We know that this is capital A, B and C, small a, B and C. And of course, we know that this is A1, B1, C1, A2, B2, C2, A2, B2, C2, A1, B1, C1. These are the three phases of primary and secondary. And here the primary is the star. Primary is a star connection. This is a primary star connection. Now draw the delta connection in the secondary. How the delta connection? Let's see here how the delta connection. Let's see here. I am drawing like this. I am drawing like this. And I am drawing like this. Like this. So actually here dot notation. And actually here dot notation in generally. But here we are taking here the terminals. So this is a subtractive manner. This is a subtractive polarity. Subtractive polarity only. Yes or no? This is a subtractive polarity only. So subtractive polarity, that's why first draw the arbitrary star. First draw the arbitrary star. Here is the A2. Here is the B2. And here is the C2. This is capital A. This is capital B. This is capital C in the arbitrary star. Yes. Now let's see here. See here. This is a subtractive polarity. That's why the vectors notation should be exactly 180 degrees. See here. Capital A is in upward direction. Here capital A should be downward direction. Here capital A should be downward direction. And B is in downward direction. B is in downward direction. That's why our B should be in upward direction. Our B should be in upward direction. And see here C is in downward direction. Here C should be in upward direction. Upward direction. This is A, B, C, A, B, C. This is the configuration. But see here, the A is connected in between A1 and B1. A is connected in between A1 and B1. B is connected in between B1 and C1. C is connected in between C1 and A1. C1 and A1. Now take the configuration. Now take the configuration like this. Now take the imposement on a clock. Imposing on a clock. This is 12 o'clock, 1 o'clock, 11 o'clock, 6 o'clock, 5 o'clock, 7 o'clock. And this is always reference one. Always this is at 12 o'clock. But see here, our small a or our hours and at this condition. So my hours and at this condition. Then tell me how it will be denotes. The primary is the star, secondary is the delta. Primary is the star, secondary is the delta, and time is 1 o'clock. And time is 1 o'clock, nothing but 0 minus 30 degrees, nothing but minus 30 degrees or 30 degrees lagging. 30 degrees lagging. Minus 30 degrees or 30 degrees lagging. This is generally the star delta connection. Star delta connection. Right? This is simply about the third one, which is 0 minus 30 degrees. And next only one is remaining. Only one is remaining. And see that remaining one, how it is. Yes, up to now, in star delta, we completed 0 minus 30, 0 plus 30, 180 plus 30. Now 180 minus 30. Let's see here. These are the primary winding, primary three-phase winding, and secondary three-phase winding. Secondary three-phase winding. Of course, you know this is capital A, B, C, small a, B, C. You know that. Of course, this is a A1, B1, C1, A2, B2, C2, A2, B2, C2, A1, B1, C1. We know that. And the primary is a star connection. And the primary is a star connection. And the secondary is a delta connection. And secondary is a delta connection. See, this is different from this. Like this. Like this. And like this. This is the delta connection, modified delta connection. Now, take the arbitrary star. Take the arbitrary star. Arbitrary star. This is A2. This is B2. This is C2. This is A. This is B. And this is C. This is arbitrary star. Now we have to draw the arbitrary delta. This is also a subtractive polarity. This is also a subtractive polarity, not additive polarity. In star delta, only first one is the additive polarity. Remaining all are the subtractive polarities. Let's see here how the vector diagram. Here A is in upwards, so here A should be in downwards. And B is in this direction. Now B should be in this direction. Now C is in this direction. Now C should be in this direction. This is our C. Now see here. Between A1 and B1. Between A1 and B1, B is connected. B is connected between A1 and B1. And C is connected in between. C is connected in between B1 and C1. C is connected in between B1 and C1. And between C1 and A1, A is connected. C1 and A1, A is connected. It's clear. Are you okay? Now let's represent the star here. Let's represent the star here. This is our actual hours angle because this is our A. Now superimpose these two. Now superimpose these two. This is 12 o'clock, 6 o'clock, 5 o'clock, 7 o'clock. Now superimpose the minutes hand. Here the minutes hand is like this. This is capital A. And this is hours hand. Hours hand is like this. This is my small a. If it is here, it is 180 degrees, but this is not 180 degrees. Now tell me, what is the notation? Primary is the star, secondary is the delta, and the time is 5 o'clock, and the time is 5 o'clock. So the answer is 5 o'clock, nothing but 180 minus 30 degrees, which is nothing but 150 degrees configuration. 150 degrees configuration. These are the 150 degrees configuration: star delta 5 o'clock, star delta 7 o'clock, star delta plus 30 11 o'clock, star delta minus 30 1 o'clock. These are the different connection diagrams for three-phase transformers. Did you understood? These are completely delta delta, star star, star delta, and delta star. Okay? Thank you, sir.